On Twitter, somebody pointed me to a story. A bunch of people pointed me to a story a few months ago where you went into a restaurant in New York. Now you can correct me if any of this is wrong. And ran into a bunch of folks from a company in a crypto company who are trying to scale up Ethereum. And they had a technical deadline related to a Solidity to OVM compiler. So these are all Ethereum technologies. So you stepped in, they recognized you, pulled you aside, explained their problem, and you stepped in and helped them solve the problem, thereby creating legend status story. So can you tell me the story a little more detail? It seems kind of incredible. Did this happen?
Yeah, it's a true story. It's a true story. I mean, they wrote a very flattering account of it. So Optimism is the company's called Optimism. It's a spinoff of Plasma. They're trying to build L2 solutions on Ethereum. So right now, every Ethereum node has to run every transaction on the Ethereum network. And this kind of doesn't scale, right? Because if you have n computers, well, if that becomes 2 n computers, you actually still get the same amount of compute, right? This is like O of 1 scaling, because they all have to run it. Okay, fine, you get more blockchain security, but like the blockchain's already so secure. Right? Can we trade some of that off for speed? So that's kind of what these L2 solutions are. They built this thing which kind of a sandbox for Ethereum contracts. So they can run it in this L2 world, and it can't do certain things in L1.
Can I ask you for some definitions? What's L2?
Oh, L2 is layer 2. So L1 is like the base Ethereum chain, and then layer 2 is like a computational layer that runs elsewhere, but still is kind of secured by layer 1.
And I'm sure a lot of people know, but Ethereum is a cryptocurrency, probably one of the most popular cryptocurrencies, second to Bitcoin. And a lot of interesting technological innovations there. Maybe you can also slip in, whenever you talk about this, any things that are exciting to you in the Ethereum space. And why Ethereum?
Well, I mean, Bitcoin is not Turing complete. Well, Ethereum is not technically Turing complete with the gas limit, but close enough.
With the gas limit? What's the gas limit? Resources?
Yeah, I mean, no computer is actually Turing complete.
Right.
We're gonna find out RAM, guys. I can actually solve the whole
problem. What's the word gas limit? You have so many brilliant words. I'm not even gonna ask.
That's not my word. That's Ethereum's word.
Gas limit.
Ethereum, you have to spend gas per instruction. So like different opcodes use different amounts of gas, and you buy gas with Ether to prevent people from basically DDoSing the network.
So Bitcoin is proof of work. And then what's Ethereum?
It's also proof of work. They're working on some proof of stake Ethereum 2.0 stuff. But right now it's proof of work. It uses a different hash function from Bitcoin that's more ASIC resistance because you need RAM.
So we're all talking about Ethereum 1.0. Yeah. So what were they trying to do to scale this whole process?
So they were like, well, if we could run contracts elsewhere and then only save the results of that computation, well, we don't actually have to do the compute on the chain. We can do the compute off chain and just post what the results are. Now, the problem with that is, well, somebody could lie about what the results are. So you need a resolution mechanism. And the resolution mechanism can be really expensive because, you just have to make sure that like the person who is saying, look, I swear that this is the real computation. I'm staking $10,000 on that fact. And if you prove it wrong, yeah, it might cost you $3,000 in gas fees to prove wrong, but you'll get the $10,000 bounty. So you can secure using those kind of systems. So it's effectively a sandbox which runs contracts. And just like any kind of normal sandbox, you have to like replace syscalls with, calls into the hypervisor.
Sandbox, syscalls, hypervisor. What do these things mean? As long as it's interesting to talk about.
Yeah, I mean, you can take like the Chrome sandbox is maybe the one to think about, right? So the Chrome process that's doing the rendering can't, for example, read a file from the file system.
Yeah.
If it tries to make an OpenSyscall in Linux, the OpenSyscall, you can't make an OpenSyscall. No. You have to request from the kind of hypervisor process, or like, I don't know what it's called in Chrome, but could you open this file for me? And then it does all these checks, and then it passes the file handle back in if it's approved.
Got it.
So that's,
So what's in the context of Ethereum, what are the boundaries of the sandbox that we're talking about?
Well, like one of the calls that you actually reading and writing any state to the Ethereum contract or to the Ethereum blockchain. Writing state is one of those calls that you're going to have to sandbox in layer 2, because if you let layer 2 just arbitrarily write to the Ethereum blockchain.
So layer 2 is really sitting on top of layer 1. So you can have a lot of different kinds of ideas that you can play with.
Yeah.
And they're not fundamentally changing the source code level of Ethereum.
Well, you have to replace a bunch of calls with calls into the hypervisor. So instead of doing the syscall directly, you replace it with a call to the hypervisor. So originally they were doing this by first running so Solidity is the language that most Ethereum contracts are written in. It compiles to a bytecode. And then they wrote this thing they called the transpiler. And the transpiler took the bytecode and it transpiled it into OVM safe bytecode. Basically bytecode that didn't make any of those restricted syscalls and added the calls to the hypervisor. This transpiler was a 3,000 line mess. And it's hard to do. It's hard to do if you're trying to do it like that, because you have to kind of like deconstruct the bytecode, change things about it, and then reconstruct it. And I mean, as soon as I hear this, I'm like, well, why don't you just change the compiler, right? Why not the first place you build the bytecode, just do it in the compiler? So yeah, I asked them how much they wanted it. Of course, measured in dollars, and I'm like, well, okay. And yeah.
And you wrote the compiler.
Yeah, I modified. I wrote a 300 line diff to the compiler. It's open source. You can look at it.
Yeah, I looked at the code last night. It's
cute.
Yeah, exactly. Cute is a good word for it. It's and it's C++.
C++, yeah.
So when asked how you were able to do it, you said you just gotta think and then do it right. So can you break that apart a little bit? What's your process of one, thinking, and two, doing it right?
The people I was working for were amused that I said that. It doesn't really mean anything.
Okay. I mean, is there some deep, profound insights to draw from like how you problem solve from that?
This is always what I say. I'm like, do you want to be a good programmer? Do it for 20 years.
Yeah. There's no shortcuts.
No.